In this final video, we are going to bring our stickman to life by creating a reusable 2D character controller template with movement and jump functionality using Unity's input system and physics. We'll also look at how we can use and edit this template as well. There's no magic shortcut or a 10-minute tutorial here. The full recording for this took about 50 minutes, but I've trimmed it down to as short as possible without losing any detail. Okay, from the previous two videos, we have looked at how to draw and create this character on Photopea. Then we've learned how to rig it, and then we've learned how to animate it. Now let's create a template so that we can reuse it again and again for all future side-scroller projects. Let's start. Firstly, make sure that we have created a prefab for the player. If there are any overrides to it, make sure to apply all of those overrides. Okay, because we are creating a template, we need to handle three different things: physics, input, camera. For physics, we are going to code using Unity's rigid body things. For the input, we are going to be using the input system. And finally, for the camera, we're going to be using Cinemachine. And I always recommend starting with the camera. We need to use the Cinemachine package. To do that, we go to Window, Package Manager, and go to Unity Registry, and then search for Cinemachine. Then hit Install. Unity will import Cinemachine into your project. Why are we using Cinemachine? Because this is great. This contains everything that you need for a game. If you want to make cutscenes, dolly tracks for custom animations, blending between cameras, everything that you need is there. So just use it. Okay, it's free. To start, we right-click Cinemachine, Cinemachine Camera. And we have a few settings. First of all, we can go to the main camera. Here, this is the Cinemachine brain. You can see an icon here. And in Cinemachine brain, we need to change the update method from smart update to fixed update because we will be using the physics system. The same goes for blend update method as well. You can use fixed update. It's fine. And there we go. Then let's go to Cinemachine camera. And we have a few procedural components that we need to use. Okay. There is a position control, which means we can have a component that defines how the Cinemachine camera's position will be controlled. We can click on none, and there's a lot of options. We can simply choose follow, and there we go. And it says a tracking target is required. We need to specify a transform as the tracking target. Now if we go to the game view, you can see things are a bit weird. We can go to the scene view itself and then just change the offset. We can offset it to something like this. There we go. And yeah, now if we go to the game and hit play, move it to the side, select our 2D character, and then just move it, and everything is golden. Whee! Now there is a little bit of jerking here, and that is because we have set the update mode to fixed update, and we're moving it inside the scene view. Once we get into the code, I believe that jerking will not be there. If it is there, then we'll deal with it. Now just to add some noise to the camera, add a basic multi-channel Perlin noise. And it says a noise profile is required. You may choose from among the noise settings asset predefined in the project or from one of the presets. So you can click on the settings, click on presets, and let's go handheld normal mild. I don't know what that does. Let's hit play and test it out. You can see there is a little bit of noise that's being added to how the camera works. And now we can reduce amplitude gain to 0.5. 0.25 is great. Frequency gain could also be shorter. Yeah, something like that. 0.5 and 0.25. Now if we go to play maximized and then play the game, you can see there's a little bit of noise here and it looks good. It feels like the player is in a actual moving world. Cool. Just in case, these are the settings. I'll move my camera. I forgot about it. So amplitude gain is 0.25. Frequency gain is 0.5. Now what do? We create a prefab of the camera. So we'll right click create prefabs and then drag and drop this camera. You can also drag and drop this platforms as well. So I'll drag the platforms to the prefabs and even the main camera. You can also create a prefab for the global light as well, just to create a template. Why not? We are done with the camera. Next is input. Input is really easy because By default, Unity 6 projects uses the input system. And if you created a new project, you will get this input actions asset already set up with all the controls that we need. If you don't have this, just create a new empty project and you'll get it, then import it to this new project. Make sure that the latest version of input system is installed. You can do that by going to Window, Package Manager, Unity Registry, and then Input System. Okay, now I have an update here. I'm going to update it. Okay, now if you double click on this input action asset, you'll see a lot of controls. Just to explain this quickly, this asset is like the player controls. We create a bunch of action maps. In here, there's already 2 action maps, player and UI. And action map is a collection of actions. Actions include things like move, look, attack, interact, crouch. These are the actual actions that you perform in game. Now, if you open each action, you will get things called bindings. And bindings are like the key controls. For example, here you have WASD. You have left stick on the gamepad. Primary 2D axis on the XR controller. If you look at look, you can see that right stick on the gamepad and delta, which is the pointer of the mouse position on the mouse. And if you click over here, there are a bunch of control schemes, keyboard and mouse, gamepad, touch, joystick, and input system makes it so much easy for you to have multiple types of input in your single game. All you have to do is save asset. And now we have 2 actions. One is move, and then one we have called jump, which is assigned to space and button south. Okay, so these are the 2 actions that we'll perform. You can also have one for attack or interact. That's completely up to you if you want to expand your own template. Okay, so let's go on to physics and let's move this character. Let's make it jump and let's call it a day. So we go to 2D character. I'm going to go inside the 2D character and then create a folder for scripts. Then I'll create a mono behavior script. Call this player controller. So to start off, we need to use the input system namespace. We can do that by writing using unity engine.input system semicolon. All right. Now, how do we start? We really need a reference to this move action and this jump action. Okay. And it is very easy to do. Firstly, you need to go to project settings, go to input system package, and then make sure that the project wide actions is set to this input actions asset here. Just simply drag and drop here. And now input system will use this package. The action name is called move and jump. Okay, it is case sensitive. Let's go back to code. Firstly, we need to create an input action called move action. Let's also create an input action called jump action. At start, we need to say move action equals input system dot actions dot find action, and let's call it move. And I'm going to copy this and say jump action equals input system dot actions dot find action jump. And now this is going to dynamically assign the proper actions. Really cool. We need to move based on physics, and for that we need to have a rigid body 2D component. Let's call it RB2D. At start, let's say RB2D equals get component rigid body 2D. Because I don't want to check for null references here, we can simply add an attribute called require component and then give a type of rigid body 2D. This is going to make sure that you will not get a null reference. Whenever you add this player controller script, it will automatically add a rigid body 2D along with it. And now that we have a rigid body 2D component, we need to make it move. We should use rigid body stuff inside fixed update. But the dilemma is we need to use input inside update. You want input to be synced every frame, but the movement should happen based on how physics engine wants it. Therefore, we need to handle input inside update. So we'll create a function like this. And then inside fixed update, we need to actually perform movement. Okay. So we'll hover over this, press Alt and Enter, and click generate method. This is going to create a method for us. The same goes for perform movement. We'll Alt Enter and then generate a method. I'm going to get rid of these exceptions. First, let's handle input. How do we want to handle the movement? If you go to input actions asset, click on move. It is an action type of value, which means it returns a value. And the control type or the data type that it returns is vector2. There are different types of data types that you can return. You can return a quaternion, you can return a touch, you can return an integer, axis is float, anything. This one returns a vector2 based on the bindings WASD. WASD also contains the up and down arrows as well, which is really cool. So we need a vector2. Let's call this move vector. And what we simply need to do is move vector equals move action dot read value. And we're going to read the value of type vector2. That is it. That is all that we need to do. Now inside perform movement, which is inside fixed update, we do the code to move. And simply rigid body 2D dot linear velocity x. So Unity has introduced linear velocity x and linear velocity y because we are only moving in two directions, left and right, in a side scroller game. So you can say linear velocity x equals something. We need a speed, so we need to serialize a variable. So serialize field float movement speed equals, let's say, 10f. And then down here we can say movement speed multiplied by move vector. This is going to give us an error because it's a vector2, it's not a float. We need to do move vector dot x, I believe. Now if we go, I will put it here, go to the game, select my 2D character, add a component called player controller. It automatically adds the 2D rigid body component as well. Firstly, I'll freeze rotation Z because I like to do that. Then I'll go to overrides and apply all. Now if I go and hit play, it won't work because we need a collider. We are going to create a capsule collider 2D. And if you hover over it, you can see it is created here. I'm going to give it a size, let's say 5 and height of 10. It is probably not enough. So I found out that this is the right collider position for me. I'm going to save, hit play, and now you can see my player collides properly. I can press left and right and move this character. It looks cool. I don't want us to be super close. So I can go to the camera, the Cinemachine camera actually. And if you hover over the lens, you can increase the orthographic size so that it's a lot more smaller. Now it feels good. And if I move over here, you can see it moves down. I'm just going to override and apply all. And the last thing we need to do for this template is jumping. Okay, we have created an input action called jump action, and we have found the jump action called jump. How do we perform a jump here? Firstly, we need to handle the input, and really jump, if you go to the input actions asset, jump is actually an action type of button. Okay, so whenever you press the jump key or the space keyboard, it jumps. Instead of handling input using the read value function, we can simply use actions. What do I mean by that? After start, we can say jump action dot performed. Then we can write plus equals perform jump semicolon. Okay, jump action dot performed is an action, which means we can assign or subscribe a function to this action. If you go to perform jump, it does not exist in the current context. But if you press Alt and enter and then generate method called perform jump, it creates a method which takes a parameter of type input action dot callback context called context. And now we can do whatever we want inside it, and it will be performed when the jump button is pressed. What is this context? Context has a lot of things. So context dot face. Okay, it has context dot performed, context dot started. You get context dot time. So you can do a lot more things with it. So if the perform jump has started, you could play an animation. But if it was started and cancelled, you can go back to another animation. So now we can say if context dot performed, we do jump. Rigid body 2D dot add force. We need to add a force along the direction upwards. So vector 2 dot up multiplied by a jump force. So we'll serialize field float jump force. Let's give it 10f as well. And then we multiply it here. We need to also specify a force mode 2D. By default, it is going to be force mode 2D dot force, which is going to treat it as a constant force. We don't want that. We want it to be an impulsive force, meaning if you press the jump, it'll be like boom. So it's an impulsive force rather than a constant force. Okay. So we should write force mode 2D dot impulse. This is going to treat it as an impulsive force, which means we might need a higher jump force value because it's an impulsive force. But let's just test it out. Play the game, and if I jump, it works. I can also use my left and right keys like this. There are a few issues. Firstly, I can double jump, triple jump. I can do however times I want. Secondly, it is slow. Okay, we don't want that. Let's fix the jumping issue first. The jumping should happen quickly. And the easiest way to do that is to increase the gravity scale and then increase the jump force. We can increase the gravity scale to, let's say, 100. We could also play around with the mass as well. Let's change this to 10. And then jump force could be 1000. I don't know. Let's just test it out. And you can see it went down quickly because it's too much. Maybe jump force should be back to 50 and then maybe gravity should be 40. Yeah, that feels, gravity could be 25. So now this feels a lot better. So now you can see the jump is quick. Jump is a lot better than it was before. It's a lot more snappy. It feels a lot more responsive to input. And the final thing is we need to make sure to stop the double jump and we need to use raycasts. And it is pretty easy to do. We create a boolean can jump, or better, let's call this is grounded because that makes more sense. And inside fixed update, after we perform movement, we say it's grounded equals physics2d dot raycast. We need to raycast from the origin transform dot position in the direction vector 2 dot down, and we need a max distance of 0.1f. We can also provide a layer mask. We can simply write serialize field layer mask ground layers, let's call it, and we can specify the ground layers here and then a semicolon at the end. This is going to always check if we are grounded. Cool. Now context.performed and not is grounded. We can add a force upwards to jump. If we hit play, nothing, it doesn't work. Why? Is because we have not assigned the ground layers. So go ahead to the platform, create a new layer called platform. You can add a layer here like this and make sure to assign the platform prefab to the platform layer. Now you just change the ground layer to platform. If you have other layers as well, just make sure to create separate layers for it. I'm going to apply to prefab. And now we cannot even jump. Why is that? Because we should be grounded. I forgot. It should be true. That's why. We should only jump if we are grounded. That makes sense. I don't know why. So now I cannot double jump. I'm smashing my spacebar right now, but it's working. Now we have our player that moves. Let's quickly make it animate. Okay. If you look at the animator, it already contains an animator for the player idle and the player run. If you need to know what the animator does, I have a tutorial on the top right. I'll just make a transition to the player run. I'll just make a transition back from player run to idle. Okay, based on a parameter, it could be simple float. Let's call speed. We'll go to run when speed is greater than 0.1. We'll go back to idle when speed is less than 0.1. Firstly, we need to go to the player run animation. Make sure that it is selected. There you go. Make sure that loop time is enabled. Same goes for the player idle animation. Then we can just go to the script. Just like how we created a rigid body, we can create an animator. Let's call it anim. And after we get the rigid body, we can say anim equals get component animator. Once you're done with that, we simply hit save. And once we handle input, now because we are creating a template, we can create an integer called speed hash And let's create a hash. Okay, this is sort of like an optimization. We can call speed hash equals animator dot string to hash, and then we can give in the parameter name, which is called speed. Okay, so this is going to convert the speed string into a hash value, which is an integer value, and the hash value is determined by the animator, not us. And this is going to return an integer, and it will be assigned to speed hash. Now whenever we anim input, we can say anim dot set float. We need to set the float. Instead of giving it a string called speed, we can just give it an integer called speed hash. As you can see, by default it is asking for an integer. If we added a string, it will do this string to hash anyways, so it's better to do it only once at the top and then provide that hash value, so it is going to be a lot more faster. We can give it move vector dot x, and let's make sure that it's math of dot absolute. So this will remove the negative value if it is in the negative direction, so that it's always a positive value. And there we go. Now let's go to the 2D character. It already has an animator. That is great. If we play the game, by default it will move animate, and it is not going to here. That is because of something called exit time. If you click on this transition, we need to remove the hash exit time, and let's give it a transition duration of 0.1 seconds so that it's fast, it snaps. Let's also remove the exit time here, and let's set the transition duration to 0.1 as well. Now if we go and play the game, hopefully it looks good and not terrible. There we go. We have a working player that can move and then jump. Now how do we flip the animation? We can do that by simply multiplying the scale x with -1. Okay, what do I mean by this? We can have a boolean called is facing right. Let's set this to true, and when we handle the input, we can set if is facing right, means if we are facing right, then we need to check if we are facing left again. We can say if again move vector dot x is less than 0f, which means now we are facing left. Is facing right equals false, and then we just create a flip function, flip sprite. Else we check the opposite. If move vector dot x is greater than or equal to 0f, then we set is facing right equals true, and then flip sprite. And we can hover over this alt enter, generate a method. And how do we flip sprite? Transform dot local scale equals new vector 3 negative transform dot local scale dot x transform dot local scale dot y transform dot local scale dot z. I don't know if there's a better way to do this, but this is the easiest way. And now we can move right, we can move left. There we go. Now just to make sure that we are still moving left, I can get rid of this less equals and just make it greater than. So it will stay on whatever direction that we have faced. So now you can see it is working really good. You can jump as well. You can tweak it down to whatever value that you want. Really cool. And there we go. We have successfully created our template. And this part of the video has took me 50 minutes. Okay. It's been 50 minutes of trial and error, mostly because I'm recording a video. I make mistakes verbally, but also it's trial and error. And I'm not going to show you 50 minutes. I'm going to skip the boring parts. And before you do anything, make sure that there are no overrides on prefabs. So just hit apply all. Just hit apply all so that it is saved. And then finally, once you're done, right click, export package. Make sure to select none and just select the things that you need. In this case, you need the 2D character folder, the input actions asset, and the prefabs. You can also have a sample scene if you want. So I'm just gonna use it here. And then I'm gonna hit export. I'm going to save it into my packages. I'm gonna call it 2D Stickman template. I'm gonna hit save. And there we go. We have a template that we can use and import to all of the rest of our projects and get started. By the way, this art is a PSD file and all of these are separate layers. You can open it in Photoshop or Photopea or Krita and then draw on top of these layers to create your own characters if you want. You can use this existing character as a skeleton and hey, just have fun with this. Just to show you how the template works, I have a blank project. With the editor open, you can either double click on the Unity package or you can right click import package, custom package, and then choose the package. You can download the package from the link in the description and then you can select whatever you want, hit import. And it will ask you to reload the scene because I've named my scene actually sample scene, and I'm just gonna hit reload. I'm going to change that for the template that you can download so that you don't get any issues. Okay, and then there we go. We haven't installed Cinemachine in this project. There's no camera movement because Cinemachine camera is missing. And we can go to window, package management, and package manager. I don't know why they made it that way, but that's with the newer updates. We can go to Unity registry, search for Cinemachine, hit install, wait for it to load. It's installed, and now you can see the camera icon close to the main camera, and you have the Cinemachine brain attached, and the Cinemachine camera works. There you go. You have the character. Now let's see how we can edit the character. I'm going to open Photopea. I'm going to open the character PSD file, which is going to be in art, 2D character.psd. There we go. Now let's say we want to make changes to this character. Okay. You just have to replace all of these layers. That's it. Let's say you want to add a hat. I'm going to use the rectangle select, something like this, and then shift select something like this. And I'm going to go to the polygonal select, alt and deselect these areas. Just to show you that this is a hat, I can create a new layer, select this color, paste it in, and this is the hat apparently. And I can actually merge down into the head like this. Let's say I want to add more detailing to the torso. I can create a layer and then merge down again. Create a square like this. Select this, Control T to rotate, something like this. And then select this, Control T to rotate, something like this. And then I'm going to make a tie. There we go. And then Control Shift T, rotate it. So we have a tie. I'm going to select this one, move it a tiny bit downwards. I'm going to select this one, move it a little bit up so that it's a lot more thinner. There we go. We have a tie. That looks really horrible. I'm going to change the fill color to white. Also with this layer as well, I'm going to change the fill color of that shape to white. That looks a lot better. It still looks horrible, but I'm just showing it to you for the example. Now I can select this, merge down, select this, and then merge down. Now we have a torso. I'm going to hit save because I'm saving it directly to the 2D character. You can save it to an edit file if you want. The only thing is these layers must be rasterized. So I'm going to hit file, save changes. And it's going to re-import Unity with all of your assets. That's all it is. Like any changes that you make will be reflected on this template. You can double check by going to the sprite editor for this thing, open it up, and you can see it re-imports or resizes the layers based on whatever change that you make. But it is a good habit to double check within the sprite editor in case there are problems. There might be problems when it comes to weight painting. You see, there are problems here because the sprite is regenerated and you need to redo the weight painting. And the whole point of the stickman is so that you can draw on top of this, use this as a skeleton, and then you have everything in place. You just need to change the sprites, redo the weight painting, and then all the animations will work because the rig is already there. Okay, you're rigging it based on the rig that we have made. You don't have to redo this rig for this character or for this proportion. You can duplicate this and then use the same rig to make an enemy character or something like that. You can go to the sprite editor, skinning editor, and there's an option called copy rig, which you can do and then paste it over there if you want the same rig, and you can reuse the same animations by using the same animation file. So it's a really good way. You can customize it to your liking, you have to do the weight painting again, but it's not the most difficult thing in the world. The things that you don't weight paint are still there, but all you gotta do is just weight paint it. So I'm gonna weight brush, I'm gonna select this, I'm gonna increase this. I am going to increase the size of the brush. There we go. I'm gonna select this sprite, the torso sprite and the green bone, and then paint on the top. Then I'm going to click on this bone, make sure that that's the one selected, and then paint over the other vertices so that the influence is there. And then just hit apply. And you can fine tune this later. You can watch the previous video on rigging if you want to know how to weight paint. Just close this, and probably now the sprite would also animate. Look at that. And that's how you do it. And now we have a very cool stickman. There you go. There's also an issue with jumping because the platform needs to have a platform layer. So you need to reset all of that. And then you need to assign the platform layer to the platform. 2D character should have the ground layer set to platform and apply it to the prefab. There are changes that you would have to do on individual projects. Now the jumping will work. You can create a jump animation as well. And we have a template, right? So how do we fix this problem? By creating a README file. You create a README file inside your own package to tell you about what you need to do beforehand. So just have that and mention you need to import the Cinemachine package. You also need to add the platform layers for the platforms and then set the ground layers to platform. Okay, I'm going to add that for you guys from the link in the description. You don't have to repeat what I did, but it's educational. Hopefully this teaches you that you can have fun with Unity and then play around and make templates, which will save you a lot of time in the future. And yeah, that's it. So I had fun with this, and that's how you use this package. And that's it. A fully working 2D character controller from scratch, built step by step. We drew the character, rigged it, animated it, and created a functional movement system. And I hope you stuck through the whole series. And I'm proud of you if you did. If you found this valuable, let me know in the comments. And maybe I'll turn this into a bigger series with enemies, weapons, or even level building. And we can create a full 2D game template. Thanks for learning with me, because this is not scripted. This was just me going through my entire thought process and journey, and a lot of this is just silent repetitive mistakes, and that was fun. So I'll see you in the next one. Take care. I love you.